Welcome to Easy Academic. In this episode of the Introduction to Linear Algebra series, we'll be discussing elementary matrices. So elementary matrices are matrices that allow us to apply the three row operations. So what are these row operations? The first row operation is swapping rows. So if we have any matrix A, a legal row operation that we are allowed to perform is swapping two of the rows within A. The second row operation is scaling any row by some value as long as that value is not equal to 0. The third row operation is adding a scalar multiple of one row to another. And so what does that look like in terms of elementary matrices? Let's start with swapping rows. Now some important context about elementary matrices is that all elementary matrices are based on the special matrix case of the identity matrix. And if you're curious about the identity matrix, feel free to go back to my video about matrices. So if we have an identity matrix, which is denoted as I, or in some cases 1, let's say we have a 3 by 3 uh, 1 matrix. So this would be equal to 1, 1, 1. So if we took this identity matrix and we had another matrix A, which had, let's say it has arbitrary entries, A, B, C, D, E, F, G, H, I. If we wanted to swap any two rows in A, we could multiply by the corresponding elementary matrix which swaps those rows. So if we transform the identity matrix I into the elementary matrix E of type 1 meaning it swaps rows, we simply take I here and then we swap two of its rows. So say we swap row 1 and row 3. We would have row 3 as the first one, so 0, 0, 1. Row 2 would remain unchanged, so 0, 1, 0. And row 1 would now be where row 3 originally was, so 1, 0, 0. Then, multiplying that by this new value for E, multiplying that by A, would swap the first and third rows in A. So let's demonstrate this. E times A equals 0, 0, 1, 0, 1, 0, 1, 0, 0 times A, B, C, D, F, G, H, I. So if you remember back to the video about matrix multiplication, here's what we'll get. The first column will be A times plus D times the second column plus G times the third column. The second column will be B times the first column plus E times the second column plus H times the third column. And the third column will be C times the first column in E plus F times the second column in E plus I times the third column in E. So if we now combine these values, we have 0, 0, A is one value plus 0, D, 0 plus G, 0, 0. And this is one column. We have 0, 0, B plus 0, E, 0 plus H, 0, 0. And this is the second column. In our third column, we have 0, 0, C plus 0, F, 0 plus I, 0, 0. And this is our third column. And so finally, we have G, D, A, H, E, B, I, F, C. And so if we now compare this to the original matrix A over here, we see that they are the same matrix except that the first and third columns are swapped. So this is a demonstration of the elementary matrix swapping rows. We can now show an example of the elementary matrix scaling rows. So now that we have a bit more intuitive of an understanding of the role the identity matrix plays, I'd like for you to pause and assume what would happen if I asked you to take this matrix A and try and find the elementary matrix that would scale the second row by 3. So as you might have guessed, if we take the identity matrix and we attempt to transform it into the corresponding identity matrix, what we'd find is that we have 1, 1, 1. And in order to take the second row and multiply it by 3, in terms of A, we simply do that transformation on the identity matrix. And so this whole matrix gets turned into 1, 3, 1. And so now what does E times A look like? This looks like 1, 3, 1 times A. And again, multiplying the matrices, we find A is 1, 0, 0 plus D 0, 3, 0 plus G 0, 0, 1. It's one column. Find B 1, 0, 0 plus E 0, 3, 0 plus H 0, 0, 1 is the second column. And we find C 1, 0, 0 plus F 0, 3, 0 plus I 0, 0, 1 is the third column. This is equal to, we can do this a bit faster now that we're getting used to multiplying matrices. We have A, 3D, G as our first column. We have B, 3E, H as our second column. And we have C, 3F, I as our third column. And so as you can see, scaling the second row of the identity matrix by 3 to get the elementary matrix E, then multiplying E by A scales the second row of A by 3. Now the third type of elementary matrix allows us to add a scalar multiple of one row to another. So to keep it simple, let's take again our example matrix A, and let's say we want to add 1 times row 2 to row 3. So again, you can pause and think what we'd have to do to our identity matrix to enable this to allow us to multiply E by A to get there. So again, if we have our identity matrix as 1, 1, 1, in order to transform it to an appropriate E, where we add 1 times the second row to the third row, what we'll do is we'll take our first row and leave it as it is. We'll take our second row and leave it as it is. But for our third row, we'll add the second row to the third row. So we'll find we have 0, 1 plus 0, which is 1, and then 0 plus 1, which is 1. So this is our matrix E. So let's now multiply by A to show that this property, again, still holds. So E times A equals 1, 0, 0, 0, 1. And then we still have our original A. And so in order to get the first row, again, we'll multiply A by the first column in E. So 1, 0, 0. Add D times 0, 1, 1. Add G times 0, 0, 1. That's our first column. Again, we'll take B times 1, 0, 0. E times 0, 1, 1. And G times 0, 0, 1. And again, we'll take our third column, C times 1, 0, 0. F times 0, 1, 1. And I times 0, 0, 1. And finally, this one's a bit more complicated to attempt to visualize, so let's do it in 2 steps. This is A, 0, 0 plus 0, D, D plus 0, 0, G. Second column gives us B, 0, 0 plus 0, E, E plus 0, 0, G. And our third column gives us C, 0, 0 plus 0, F, F plus 0, 0, I. And finally, we obtain EA is equal to A, 0, sorry, it's equal to A plus 0, 0, 0 plus D plus 0, and D plus G. We have B plus 0 plus 0, 0 plus E plus 0, and E plus G. Oops, sorry, this is supposed to be H. So this is actually H. So what we have actually is E plus H. And then here we have C, F, and F plus I, which we'll observe is the same as D, E, F plus G, H, I. So the second row from the initial third row in A. So I hope this video was helpful if you were looking to attempt to understand elementary matrices. If it was, be sure to like and subscribe. If you have any questions, be sure to leave them in the comments below. I'll try to help you out with those. Thank you.